Okay, today we're going to be looking at density. So before we get into density, let's think about this. Which do you think would have a greater volume and mass, and why? So we're comparing 100 feathers and 100 rocks, okay? Now think about the volume first. Which would take up more space, okay? Now feathers, they take up a lot of space, right? They're not very small things. Rocks, on the other hand, can be super small. So we can have 100 rocks probably just in like a handful. Mass is, though, something different, okay? Feathers individually have very little matter. There's lots of air in them, whereas rocks have a lot of matter in them, so they're going to have a lot of mass. When we're comparing these two things, then we notice that feathers have more volume but less mass, and rocks have more mass but less volume potentially. Okay, and when we're looking at those, we're looking at density. Okay, density is defined as mass per unit of volume. It's a measure of how tightly packed and how heavy the molecules in an object are. Density is the amount of matter within a certain volume. So in order to compare how dense something is, we have to boil it down to the same volume of each, okay? So we need the same volume of rock and equal volume of feather to be able to compare the two. Proof that water and ice have different densities, okay? If we think about ice, it floats, right, on water. Now, things that float on top of other things are less dense. They have less matter per their volume as compared to the other thing. So whenever we have a thing that's layered, we have the things on top being less dense than the things on bottom. Okay, so thinking about that, which of these is the most dense to the least dense? So I want you to write down most dense to least dense in this column here. Okay, take a second to do that. Now, hopefully, you wrote the most dense things as the lower ones, okay, and the least dense as the higher ones. Okay, to find density, first we need to find the mass of an object or substance. Second, we need to find the volume of that object or substance. And then we need to divide. Mass divided by volume is equal to density. Something helpful for you is this triangle. Okay, we have mass on top, density on the left side, volume on the right side. Anytime we cross a horizontal line, we're dividing. Anytime we cross a vertical line, we're multiplying. Okay, and what this allows us to do is to know these three variables and plug them in to find the third. Okay, so if we want to find mass, we need to do density multiplied, because we crossed that vertical line, times volume, okay? So what I like to tell students to do is cover up the thing that you're trying to find and then use the rest of the triangle as your equation, okay? So you have three different equations that we can get from this triangle. Units for density are grams per centimeter cubed or grams per milliliter. Let's do a practice problem. Remember, you're going to find the mass, find the volume, and then divide. If the mass of an object is 35 grams and it takes up 7 centimeters cubed of space, calculate the density. Okay, to do this, we need to identify what we're given, figure out our formula based on what our unknown is, and then do the math. So we're given the mass, we're given the volume. Where unknown is density. So we're going to do density equals mass divided by volume, plug in our numbers, and we get 35 grams per centimeter cubed. Now another practice problem. Find the density of a substance with a mass of 17.63 grams and a volume of 43 centimeters cubed. So we're given mass, we're given volume, okay? Density is the thing we're trying to find, so we're going to use density equals mass divided by volume, plug in our numbers, and we're given our answer, okay? Don't forget your units here, okay? We didn't cancel any units, so we need to use both of those. Now, notice here that our answer is 0.41 grams per centimeters cubed. Based on your calculation, what is the identity of the substance? So we're given some different substances and their densities here. Our answer on the last one was 0.41, so that means that whatever that substance was is likely this amabilis fir species of wood. Okay, any more practice problems given on your note sheet, go ahead and do them, and then feel free to check your work with your teacher's key, ask your teacher any questions, and move on to the next topic.